Welcome back to the theanimechemtutor. In this video, we will define the terms mass number and atomic number as it relates to the atom and look at some examples and ways of working out the mass number and the atomic number. Select any element in the periodic table, say nitrogen for example. Nitrogen has the symbol N, and to complete the overall representation we must add a number to the top left of the N and another number to the bottom left of the N. Nitrogen falls in position 7 in the periodic table because it has 7 protons. That 7 will be the number that goes to the bottom. The number that goes to the top is 14. This number represents the mass or weight of the nitrogen atom when measured against the carbon-12 scale. The carbon-12 scale is the standard scale that all the elements in the periodic table are measured against. Here is a representation of the nitrogen atom. Alright, so let us make sense of what we're looking at. The top number has a name, and it is called the mass number or the nuclear number. The mass number is the protons plus the neutrons, which is 7 protons, 7 neutrons, which gave a total of 14 AMU. And remember earlier I said that the mass number represents how heavy the atom is, the weight of the atom. And in chemistry, mass and weight are used interchangeably. Alright, so let us take a look at the lower number now. That is on the bottom left side of the nitrogen atom. This number is called the atomic number, but most students who are just starting out with chemistry may have difficulties trying to remember if the atomic number is above or below. So I came up with this gig by rhyming atomic with batomic. Get it? Atomic, batomic. So there shouldn't be any difficulty trying to put the atomic number in its appropriate position. In a neutral atom, and these are atoms that haven't partaken in any form of reaction whatsoever, they are neutral. The number of protons must equal the number of electrons. Remember that protons are the positively charged particles and electrons are the negatively charged particles. So if the atom is neutral, the positive must equal to the negative. Hence, the number of protons equal the number of electrons. And earlier we used nitrogen as an example. Nitrogen has 7 protons. Can you guess or can you work out the number of electrons nitrogen should have? Because nitrogen is a neutral atom and it has 7 protons, it simply means that it must have 7 electrons. Not only does the proton number or the atomic number tell you the position in which the atom falls in the table, there are other useful information you could get from that, such as the type of element you're talking about, whether it is a metal or a non-metal, the type of reaction the atom will undergo, the type of bond the atom will undergo, whether it's a covalent bond or an ionic bond or metallic bonding. So there are a lot of useful information you can get about the atom by just looking at the atomic number. Let us go through some typical examples of questions surrounding the atom. We start with the fluorine atom, which looks something like this or is represented like this: F19 at the top, 9 at the bottom. And they are asked to identify the number of protons, the number of neutrons, and the number of electrons in this atom. So let us look at the information that we have. The 9 at the bottom is the atomic number, so that represents the number of protons. The 19 at the top is a combination of the number of protons and the number of neutrons. So if 9 is at the bottom for proton, and 19 at the top. Let us rearrange it and do some subtraction. 19 from 9 give us 10. So that's 10 neutrons. We already have 9 protons. Now let us try to identify the electrons. And given that it is a neutral molecule, the number of protons equal to the number of electrons. So that is 9. The number of particles in this fluorine atom are 9 protons, 9 electrons, and 10 neutrons. Let us do another example. Aluminum. The atom for aluminum looks something like this, or the atomic representation for aluminum look like this. Al, 27 at the top, 13 below. And we are asked to find the number of subatomic particles in this element. What do we have? We know that the atomic number or the batomic number is the number of protons. We know that for a fact. So that's 13. What else do we know? We also know that the mass number or the weight of the atom, that is the number at the top, is a combination of protons and neutrons. So that is 13 plus x give us 27, and so that is rearranged to find x if x represent the number of neutrons. So it's 27 minus 13, which give us 14 neutrons. We are not complete as yet. We need to find how many electrons in this neutral aluminum atom. We know that because the atom is neutral, it's not in any form of reaction, then the number of protons equal the number of electrons, right? Opposite attract. Positive for the protons, negative for the electrons. They are equal. So it's 13 electrons we have in aluminum. Now pause the video and try these examples. Carbon, the carbon atom, which looks like this, 12 and 6. So 12 at the top, the carbon, and 6 at the bottom. And calcium. So calcium is 20 at the top. Sorry, calcium is 40 at the top and 20 below. Try those. All right, so for carbon, it is 6 protons, 6 neutrons, and 6 electrons. For calcium, it is 20 protons. The atomic number is 20. And remember, the atomic number is the same thing as the proton number of protons. 20 protons, 20 from 40 is 20, and given that no reaction taking place as yet, 20 protons equal to 20 electrons. Very good. All right, so moving to another type of example where in this case you're given just the mass number, the element is unknown, and they're asking for the subatomic particles. So the number of protons, the number of neutrons, and the number of electrons, as well as identify which element it is. So let us use the question sign to represent the unknown element. And you are given the mass number of 23, but no atomic number, so that is blank, but you are told that it has 11 electrons. And you're asked to identify the element or the atom and the number of protons in this element. So the first thing, what do we know? We know that this neutral element has 11 electrons, and if it's 11 electrons, that is also 11 protons. Now that we have the protons, we can easily identify or find the number of neutrons in this element. Since mass number subtract the number of protons will give the number of neutrons. So that's 23 minus 11 is 12 neutrons. Which element in the periodic table has a mass number of 23 and an atomic number of 11? So we go to the periodic table and look at position 11, starting from hydrogen, and count 11 spaces. and we end up at sodium. The unknown element is sodium, 2311. Let's look at another example. You are given the unknown element. You need to find out what that element is. But this time you are only given the number of neutrons, which is 16, and the number of electrons, which is 15. And you're asked to find the mass number, find the atomic number, and identify which element it is. You can pause the video and try to identify which element. If you got phosphorus, then pat yourself on the shoulder. Job well done. What information do we have? The number of electrons is 15, and proton must equal electron in a neutral element, so that's 15. And we were given the neutrons as 16. To find the mass number, we add the number of protons plus the number of neutrons, which turns out to be 31. Then we count 15 steps starting from hydrogen. We landed on P. So the unknown element for this is phosphorus, that has a mass number of 31 and an atomic number of 15. So those are some typical examples in identifying the unknown element given neutrons or protons or electrons. Very easy stuff. Thank you for watching, and see you soon.